Hello everyone, this is Joshua. Registration number UR24CS123. So this video is in reference to the fifth experiment of a compiler design which deals with the simulation of deterministic finite automata. So first of all, this is a Java program which simulates the automata. So the automata of course consists of, it expects a set of inputs such as the alphabets and the transition states and the number of states that it's supposed to uh, have. So first of all, in the class compiler 5, we create a multi-dimensional array of integer type called transition, and we assign the size 2020, and we declare two variables, alpha set and state set, and we create two set lists, array list and set, both of one of character and one of integer for the alphabets and the final states. Then we also create an integer one. And now in this class built a DFA through an exception and a buffer reader, that is input stream reader, that is the number of that's the input that is to be entered by the user, and you prompt the user to enter the alphabets in the alphabet for the alphabet set and put that in alpha set, and then you take the number of states from the user and put it in the variable state set. And now then all the alphabets of the DFA have to be entered simultaneously. That is put in alphabet, and everything is read through the BR thing. And then in the for loop, I will range from 0 to the length of the alphabets that the user has entered. And as long as this condition is satisfied, this statement, that is alphabet dot add all the alphabets at character dot add this statement is executed. Followed by this, there's another for loop s, new variable int s, which starts from 0 to state set. It keeps incrementing until it gets equal to state set, and then it will go on asking you for the row entries of transition table, whatever row entries that are pre-entered for the automation, and that is put into a transition, two-dimensional array transition. And the final states variable is created, and we create a new set list of integer type, and then the user is prompted to enter the final states of the DNA, and when the minus 2 is entered here to stop, and here while into, that means that is when the user enters minus 2, it takes it to be the final state and stops. And so now moving to the next function, that is DFA test, it throws another exception. Uh, Buffer reader again to take the input. So enter the starting state and you give the input to the DFA, and uh, uh, the input is has to be entered with an identifiable character so that the program knows when the string is going to end. So the input, when it reads the hash character, it knows that the input is over, and then the index is given as 0. So while this is hash, it will take the index 1 as the alphabet of the first character, and the transition state -1 and the index 1, and the index is then incremented. And then we display the final state after giving the input. Then if final states contain the state that is entered by the user, then you say that the input string is accepted by the DFA. So if these conditions are not acceptable, that means that the final state is not entered by the user. I mean, is not contained in the state entered by the user. Then the input string is not accepted. Now in the main function, we create a raw build DFA, a new variable raw compiler 5. That's it. So when the program is run, first it asks me for the number of alphabets, and I say 2, that is A and B, and then number of states. So 4 states, the DFA has 4 states with 2 alphabets. So A and B. And then you enter the row entries. First I gave it as 2 and 1, 2, 3, 2, 4, and 2, 1. And then I enter the final state, that is the 4. And then when the inputs are done, enter -2 to stop, and I enter -2. And so there are 4 states. And then I enter the starting state. 1 is obviously the starting state. And I give the input ending with a hash character. Here you can see AABB. I've given the input as AABB. So according to the language that I've prescribed here, AABB is accepted by the DFA. and it says that the input string has been accepted by the DFA, and the final state is also displayed, that is the fourth state. That's it for the fifth experiment. Thank you.